This is Calculus Part 10. At the end of Part 9 we had to cut the video short. We were talking about how the inner ring's contribution to this torque is this number times stress max. The middle ring's contribution, this ring right here, its contribution was that number times stress max, and the outer ring's contribution was that number times stress max, and you add these three numbers together, you get that. So these numbers, these top numbers, which all add up to that number, the units for that number is inches cubed, because we're talking about area times radius, and inches cubed times stress, which is pounds per square inch, gives us inches cubed times pounds divided by inches squared, which is inch pounds, which is the correct units for torque. So we turn our 123 foot-pounds into 1,476 inch-pounds by multiplying that by 12, and we say it's equal to that many inch-pounds, stress max times that. So to find the maximum stress, we divide that 1476 by that 0.0782, blah blah blah, and we get 18,867 pounds per square inch for our maximum stress out at the outside of our shaft that is being torqued. This number is about 6% higher than the 17,819 pounds per square inch that we got by using our formula that we obtained, that we derived by using calculus. So if we were to continue with this sliver method and use more slivers and just have twice as many rings here, instead of every 1/8 of an inch, we'll make it every 1/16 of an inch. Okay, we will have an estimated answer that comes a lot closer to the correct answer of 17,819. Here's our 3/4 inch shaft divided into more rings. Our last one we only divided into 3 rings. This one's divided into 6 rings. The more rings we divide it into, the closer our estimation is to the real stress in the shaft. Okay, let's say here are all the numbers. There's no point in going through all these calculations. You do them the same way we did in Part 9 with the 3-ring division. But we can go ahead and look at one of them just to refresh your memory. Let's look at this outer ring here. Okay, this is a 3/8 inch radius, 3/4 inch diameter, 3/8 inch radius shaft. So it's 3/8 of an inch from the center out to this outer edge. So the radius to the middle of our ring, of our outer ring, will be a little less than that. So that's 3/8, that's 2/8 right there, so that's 2.5/8, which is 5/16. Let's see, which is 10/32. So if that's 10/32 and that's 12/32, well then halfway between those two would be 11/32. So that's the radius to the middle of our outside ring here. Okay, so the area of our outside ring is going to be the area of the whole thing minus the area of all these other rings inside it. Let's go ahead and go through that. The area is pi times the radius squared. The radius is 3/8 of an inch, so 3 divided by 8 equals 0.375. Okay, that's squared times pi equals 0.4417, blah blah blah. That's how many square inches the whole thing is, so let's store that. Now let's figure out how many square inches are inside of that so we can subtract them. Well, this radius was 3/8, so this radius here was 3/8 minus 1/6 of that. What would that be? Yeah, this would be 2/8 right there, so it would be 2.5/8 to the inside of our outer ring. So 2.5/8 is 5/16. So let's say 5 divided by 16 equals that. Now we'll square that times pi equals that. So we'll put a negative in front of that and add it to our area of the whole thing. Plus recall equals 0.13499. Okay, that's where we get this number. This is the area of our outer ring. Okay, and the length of this arrow from the center to the middle of the outer ring is 11/32. So that area times that distance times 11 divided by 32 equals 0.046, 402,918. Okay, times the stress of this outer ring, and we're assuming that the stress in the outer ring is what the stress would be halfway between the inside and the outside of the outer ring, which will be the maximum stress times this factor of that, which is most of the way there, that divided by that. Okay, or 11/32 divided by 12/32, which is just like saying 11 divided by 12. So times 11 equals divided by 12 equals. So we have 0.042536008 times, or 0.042536008 inches cubed times stress max. That's the contribution of our outer ring. We figured the rest of these the same way. We add them all up just like we did with our 3 rings, and we get this number, 0.081684472 inches cubed times stress max equals our 123 foot-pounds, which was 1,476 inch-pounds. So if that many cubic inches times our stress max, which is going to be in pounds per square inch, equals that many inch-pounds. To find stress max, we divide that by that, and we'll get 18,070 pounds per square inch, which is 1.4% higher than our correct 17,000 something